Alright, 3.6, Factoring Polynomials. So we're looking at a couple of things that are important. First of all, we're looking at remainder theorem. Remainder theorem is a theorem that when you're given a polynomial f at x is divided by x minus a, the remainder is equal to f at a. And the factor theorem says that x minus a is a factor of f at x if and only if f at a equals 0. So what do these two things have in common? Well, understanding this is, in essence, this is a special condition of the remainder theorem. Basically, when you're asked to determine the remainder, you could just plug in the root of the divisor, plug the root into the equation, and the result will end up being the actual remainder of the particular function. Now, let's say you plugged in that particular root, a, into the function, and the result turned out to be 0. What does that tell us? Well, it tells us that x minus a is actually a factor of that function. I think that's pretty cool. We can really use this to our advantage. So let's continue and see how. Example number 1, you're asked to factor x to the power 4 plus 2x cubed minus 23x squared minus 24x plus 144. And you're asked to factor this. So how are you going to factor it? Well, let's start off by figuring out what possible numbers could we have as a factor. So possible factors are as follows. What is all of this? Let's go over this really slowly. We're going to move back just a little bit and try that again. So, possible factors include, now, how we do this is we look at the last number and determine all the possible factors of that number. We look at the first number, okay, and we have to divide by that number. In our case, lucky for us, our first number is 1. So we made an easy one for the first time. So, what are the possible factors of 144? Well, there's 1 plus or minus 2 plus or minus 3 plus or minus 4 plus or minus 6, 8, 9, 12, 16, 18, 24, and 30, 36, 48, 72, and finally 144. Now, you have to be careful again. If you had a number in the front, you would have to divide all of these numbers by all the possible factors of the numerator. Of this leading coefficient. So be very careful. Now, why these three are highlighted are usually the three that I would say you look for the possible factors. The goal here is to find out how to factor that function. Basically, you need to find what factor will result in a remainder of 0. So we're going to test those 6 numbers, plus or minus 1, plus or minus 2, plus or minus 3. And we let the equation equal f at x, and we're going to try and plug in f at 1, and we don't get a 0, f at 2, and we don't get a 0, f at 3, oh, we finally get a 0, folks. So, plug it in. And what are we actually plugging in? Don't forget, 3 is the root, x minus 3 is the factor, the minus 3 in the factor is the part that we need for synthetic. So, we plug it in, and we use the coefficients, make sure there are, because it's a quartic, there has to be 5 terms, and there is, so there are no extra zeros. And lo and behold, this is how we do synthetic division. So I'm just going to go over this very carefully with you. Don't forget, you bring down the 1, multiply, subtract, multiply, subtract, multiply, subtract, multiply, subtract. The result should be 0. How does this help us? Well, folks, we didn't really need to use all of this. We didn't have to state any of this. We could have done it essentially in our head. This stuff is actually not important. Here, the only time the possible factors are important is to check if our answer makes sense, and it's also used as a way to see that you understand all the possible factors. But on the test, you will be told when and if you need to state all possible factors. So, one more time, this part over here, we're going to make that part disappear. And really, we only needed this part here. But don't forget, we do need to know why we did this and how come we chose this value. Well, that would be because the remainder is 0, x minus 3 is a factor. That's what you have to write. Because the remainder is 0, therefore x minus 3 is a factor. So you've proved it's a factor. How does that help us? Let's continue. Well, we've now eliminated all the possibilities so that we can factor it all over again. What you see green stroked here are all the numbers that didn't work. That are no longer possibilities, because now we're looking at the final number, the last number, right here being a negative 48. So what numbers go into negative 48? And we find out that all of these numbers go into negative 48 with the exception of the green ones. The green ones do not. So now we have the factors of 48. We start this process over again. So we do as follows. Fill it all in. Okay? And now we do it again. We're going to do synthetic division again. So synthetically divide. This time we're going to try negative 3 again. Funny enough, when we do negative 3 again, we can do the following. We do that, and lo and behold, we get a 0 again. Because we have a 0, that means that, okay, now look at that for a second. What was that was just written there? This statement here over here, this statement over here, means that it is x cubed plus 5x squared minus 8x minus 4. 48, sorry. And why was it minus all of this? This is actually ends up being the quotient. But what we're trying to do now is now factor it again. And we're factoring it again to reduce it down to a quadratic. The reason why we're reducing it to a quadratic is that will allow us to factor. Now, some people like to use synthetic division again. You can do that. Or looking at the actual quadratic and actually factoring it is so much easier and so much faster. So these here, folks, are the factors of the function f at x, which is the original function. And note that x minus 3 is squared, as well as x plus 4 is also squared. All right, next part. Part B. 4x to the 4 plus 12x cubed minus 13x squared minus 33x plus 18. What are all the possible factors of 18? Here they are, folks. But now we have to divide by all the factors of the leading coefficient, which are as follows. Okay, one more time. These are the numbers that are factors of 18. Take each of these numbers and now divide them by the factors of the leading coefficient. Leading coefficient is 4. That's this number over here, folks. So, this number over here has factors of 1, 2, and 4. And we need to divide each of these by 1, 2, and 4. 1, they stay the same. 2 means that you're dividing. You're dividing each one of these by 2. But 2 divided by 2 is 1. We already have that. 3 divided by 3 is, 3 divided by 2. We don't have that. That's included. And so on until the ones that are not included have to be considered. And then we have the next one, which is all the numbers divided by 4. So 1, 2, and 4, they're all divided by. So these are all the possible factors. Again, stick to our tried and true. Tried and true is 1 and 3. And sure enough, number 2 turns out to be our sticking point. Okay, so instead of plus 2, we're actually going to use negative 2. X minus 2 is going to be our factor that works. So prove it by plugging in plus 2 in here. So x plus 2. Negative 2 is the root. X plus 2 is going to be our factor. So we're going to have all of these values here. Plug it in. And lo and behold, we get a 0 again. What does that 0 mean? Well, it means that x plus 2 is a factor for this equation. So the remainder is equal to 0. Therefore, x plus 2 is a factor. Here's our function. And now we can continue on doing long division until we get the right answer. All right? So here we go. Long division again. X plus 3 is a factor. And finally, we have a quadratic, which we factor. And we have all the possible factors. 2x minus 1, 2x minus 3, x plus 3, and x plus 2. All right. Now, let's look at the last one. We're looking at page 177, number 13. Talks about given a function where you're missing a value k, determine the value of k. So, it says that if I divide the function by x plus 2, this answer is going to be 2 times the remainder from the function divided by x minus 2. Alright, so that's from the textbook. So we're going to answer this question. Very important to note. When you divide by a number, and it talks about a remainder, you know you're looking for probably remainder theorem at least. This is saying that if I take the root of this, which is negative 2, plug it into the equation, the answer is going to be double the remainder from when you plug in 2 into the equation. So, f at negative 2 is equal to 2 times f at 2. Alright, f at negative 2 is to find the remainder for f at x over x plus 2. The second part, f at 2, is to find the remainder for f at x over x minus 2. So this results in what they were talking about in the question right here. So now we have to solve this. So plug it in to the actual equation, and what you end up with is a bunch of numbers and some k values. Collect like terms with the k values when you plug that all in and expand it. Isolate for the k values, and you end up with a value for k of negative 6. So that means that in here, the value of k in the equation has to be negative 6 for this to hold true. Alright, that's the end of the video, folks. Take care. Have a good night.